Recitation syllabus. This is part 2 of the recitation syllabus of the revelation of the evolution of the Earth and the universe and the Earth and the human family tree. When one studies the sun, one sees it moving in a horizontal manner from the east to the west, in a horizontal semicircular manner from the east to the west, and the moon moving in a horizontal semicircular manner from the west to the east. And one can follow that for 24 hours, and for 12 hours follow the sun in the morning, where it starts and sets in the west in the evening at 6 p.m. and where the moon starts the journey by traveling from the west to the east from 6 p.m. to 6 a.m. to set at 6 a.m. in the east as it sets and the sun rises in the direction. So what one considers in part 2 of the evolution of the evolution of the ecosystem is the Earth that one is standing on. It is actually a plate. It is actually a plate like a plate where one can eat on, or a record plate, or the Earth itself is circular. It is circular. It is a circle which rotates at a very high speed, and through its evolution, through its revolutions, when one studies it, and those are my deductions from observation. I have observed this ecosystem. I have observed this Earth and this ecosystem for a long time, long enough to be able to be able to deduct these observations scientifically. And these are my observations, my personal observations, which I have confirmed scientifically, and which can be confirmed by everybody else scientifically by measuring, by studying my observations scientifically, and astronomically. So astronomically, what happens is that the Earth rotates in a clockwise manner. It is like placing a plate on the table, and placing a coin or an object, a round object, on one side of the plate, and another object on the other side of the plate, and then rotating the plate, like spinning the plate like spinning a coin, how one spins a coin. And then one would observe the part 2 of the revolution of the Earth systems. And that is what I've been studying for some time. How I rotate, how the Earth rotates when I stand in the middle, how the Earth rotates, how the Earth rotates on the high table. It is actually a high table of aliens. The Earth is actually a high table on a universe, in a universe of different objects which look like they are close to Earth, but when one approaches it, one finds them distant and more distant to Earth. And what I deduct is, by judging the distance of the sun from the Earth, that I can never reach the sun, is in the sense that I can never reach the objects which are further from the sun in a vertical manner, in a vertical fashion. When I look up, due to my deduction that I cannot reach the sun and the moon, I cannot reach the stars, because the stars are higher than the sun, and that means that the sun is a bigger object than, for example, a similar object on the ground, which I will reach and will look big, but I will be able to have found it with cameras and the internet. And that is actually the internet that I studied, that has been rotating me, and on the Earth. That when I rotate the Earth, when I rotate the plate, the plate will move. When I rotate the plate clockwise, slowly it will move the object which resembles the sun. Or when I draw the sun on one side of the plate and the moon on the other side of the plate, it will rotate the sun and the moon in equal velocities, in equal speeds. And when I accelerate the movements of the plate, it will still accelerate the sun and the moon in equal velocities. So that what happens is that the Earth accelerates the sun and the moon at equal velocities, but the sun and the moon move at equal velocities, although the earth accelerates. In general, the earth moves at a higher speed, although the sun and the moon move at the same speed, at a higher speed, but at the same speed, so they maintain their speed, the distances towards each other, but the earth increases its speed, that it decreases the time that it takes to cover a different to cover the speed. It increases the time that it decreases the time that it takes to cover the distance between the sun and the moon. That means that when I rotate the plate from the morning to the evening, every hour I rotate like a clock. When I draw it on a clock, every hour I rotate it at a notch, a point, or a digit from morning to evening. It will take 6 hours for me to cover the distance of that my symbol of the sun will takes from the left side of from the left side of the plate to the right side of the plate. But when I increase the distance, it can even take a second to cover this distance that the sun needs to cover from the left to the right. And so what I study is the stability of the plate, the stability that the plate has while covering this distance. What happens when the Earth needs only 1 second to move from the east to the west, and that means that the Earth also rotates from the east to the west with the sun and the moon. And that means that we have to consider the possibility that the Earth rotates from the east to the west. That it is in the morning, it is in the east, and in the evening, it is in the west. And that is also the bird's eye view of the Earth. The worm's eye view of the Earth will be that the sun moves from the east to the west, and the bird's eye view of the Earth will be that the Earth moves from the east to the west. And those are the two eye views that I normally deduct while studying the Earth as a plate or a CD or a DVD moving from the east to the west, or moving clockwise, in a clockwise manner at speeds which are faster than 1 second, or a DVD which needs less than 1 second, because it is small. One, it is small, and two, it is traveling at a high speed and can cover this distance in less than 1 second. And that is actually, those are the movements that I study of the objects inside the objects on the plate, or on the CD, or on the record plate, or on the CD plate, and inside the record plate, how stable the objects are, and how biomechanically stable the objects in the CD are. The objects in the CD, when one watches a video of a similar CD moving concurrently, simultaneously, at a different speed to the speed that a video is being seen, or is being watched, or is being recorded, or is being seen. So that I watch the velocity of the CD, and I watch the velocity of the people moving on the Earth, the velocity of the Earth on the screen, and the velocity of the Earth on the plate, and I compare the speeds, the acceleration of the Earth in the CD or DVD player or recorder, and the acceleration on the screen. This is actually a movement which can also be projected by digits in different master devices like MP3 players and computers, which depict this movement in a different polygonal structure, like a square structure, a square movement or a straight line movement, a straight movement of music. A straight movement of music data from the left to the right on a computer screen. And that is the movement of the song. The 3 minutes movement of the song from the left to the right is different from the 3 minutes movement of the CD from the left to the right in a clockwise manner. In the same clockwise manner, the movements are different. And I studied these movements to the critical point where the Earth becomes unstable, or where the CD becomes unstable and starts destroying itself, but due to its weight, or either due to its weight or due to its inability to move in a medium. And my logical conclusion is that the medium through which the sun moves determines the velocity, the velocity of the velocity of the plate of the CD or of the Earth. The medium determines the velocity, and the frictional force that of the medium, the density and the density of the medium determines the velocity of the Earth or of the plate in the different mediums. So that my conclusion is that it is possible for the Earth to break apart in a dense medium, like in a frictional environment, which can cause heat, and heat can cause objects. Heat can cause a CD to burn. Heat can cause a whole DVD recorder to burn. Like an electrical short circuit, or an electrical short circuit, or accelerating the CD, accelerating a DVD in a CD player, for example. It can scratch the CD, or putting in a CD that is scratched in a DVD player, a CD that has been scratched or that has objects on it that is not clean or has objects on it. It can cause the CD to get scratched, to produce breaking, screeching sounds, and then scratch. And those are, for example, just possible outcomes, possible situations. Those are situations which can cause possible catastrophic outcomes for the Earth. And similarly, one can find such similar environmental factors in the sky, like fire. When there is fire in the sky, or for example, when during summer, the Earth, during summer, or when the sun at midday, when it is so hot, it can combust a region, like the way it can combust a region, or it can dry up. It can combust a region and make it uninhabitable for a lot of living beings, flora and fauna, like the Sahara Desert, for example, at such an equatorial center, quite close to the ocean, quite close to the Mediterranean and Indian and Atlantic Ocean, that it is possible with such other optimal factors to create a heat zone which makes the zone unsuitable for flora and fauna, for living beings, both animal and plant life, unsuitable for animal and plant life. And that is actually what I study while studying the human, the flora and fauna, the plant and animal life, how they converge on each other, and how they diverge on each other, and how they move across this plate. How they move across this plate, how dependent they are on the velocity of the Earth in the environment, in the universe. And when one studies it further, when one studies beyond the sun and the moon, when one looks over the plate, when one looks over one's plate, one will find that the acceleration of the Earth can cause it is actually a very stable Earth, which does not lose its a lot of solid elements, or solid components of its plate to the environment, to the universe. But it is possible to lose components of this Earth, or the Earth itself, to the universe, because when one studies it, one imagines the possibility of this Earth being looked at from a bird's eye view, from being looked at a microscopic distance. So that when one looks at the Earth at a microscopic distance, one will not be able to see the whole expanse of the Earth. One will not be able to see that. When one is not able to see the distance of the Earth from the left, from the east to the west, when one is not able to measure that with a micrometer, screw gauge, or with different microscopic measuring instruments and appliances and sets, it means that one is looking at the Earth at a microscopic distance. At a bird's eye view, a microscope is an object that one looks through from the top to the bottom, and then one sees an organism in an enlarged form which in an enlarged form is like looking at a bean or at a small leaf in under a microscope, that one is not able to measure its distance from the left to the east, to the right, or from the east to the west, and that means that one is looking at it too close, and one is not able to look above one is not able to see the expanse, or the real one is not able to see the real size of the object. And that means that in that case, that my conception of the Earth is also just an optical illusion. It is possible that the Earth is just as small as it looks like under a microscope, and that the other, what I see is under a microscope, is just a bird's eye view of a microscope, and a one's eye view of a microscope. And the macroscopic aspect will be that that it is possible that all these other plates or these other stars are also Earths, or round objects. They are also round, or geometrical objects that one can also look through in a microscopic and macroscopic aspect. Macroscopic aspect will mean that one is looking at an object and at a different magnification. It is just magnification medium. That the magnification is defined by the medium through which one is looking through, the optical medium which one is looking through. And the optical medium, an optical medium is like a lens, like a glass, or which one is refraction. That is the refraction, like refracting, looking at an object which is enlarged with through convex lenses, that the object looks larger than it is. And when one looks at it through concave lenses, one will find it smaller than it is, and that is a macroscopic aspect, the concave aspect, and the microscopic aspect is the convex aspect of looking at an object. And that is actually, those are actually movements that one can study on a table. Those are objects that one can bring onto a table and study, and be able to label them, and be able to follow their movements with movements make one can be able to make experiments to make structures with structures, make structures, and try to follow their movements with simple structures, and try to follow the movement with simple structures, and try to understand the universe astronomically and geographically. So that geography is just the microscopic view of the world through convex medium, like the eye. The eye is a convex medium of studying an environment. It is a convex medium of studying an environment, like a spectacle. And there is also the possibility of studying the environment through a concave medium, like the concave medium will be like the sky, which looks round from the top. The sky looks round, and we study it like people looking through a big eye. The people looking through a big bowl. The eye looks like a bowl. The sky looks like a bowl, which is round inside, and round inside, and which looks like a big round inside. It's convex, like an eye, like the eyes of the living of animals. And on top of the sky, it looks also round, but it looks in a different fashion. So that when one has ever stood before a mirror, which is two mirrors, one which is convex, or one which is convex and one which is convex, like spectacles. When one looks through spectacles, the point, like, is like looking through eyes. So that when a person looks at the eyes, they perceive objects bigger than perhaps they are, depending on the magnification of the lenses, on the thickness of the lenses. And when one looks at the eyes themselves, they look smaller. They look small, and they are able to perceive environments which are actually bigger than their own bodies, or their own organ systems, or the other organisms in which they are. They are able to perceive them as possible, as equal the objects that they study as equal dimensions, though they are bigger in dimensions in the geometrical sense, in the density, mass and density and volume and velocity sense, and time and distance sense. So that it is actually just the Earth the Earth and the Sun that one studies above and below the sky. So that one studies the Earth, the sky below the sky below the sky. One would look at it through human refraction, and when one studies the Earth through from the sky, from the universe, one studies it like a human being looking through eyes or looking through spectacles, through human spectacles from the terrestrial point of view, or from the human point of view, or from the optical point of view. So that it is actually an objective deduction that I've made of the universe.